So we learned about some special features of a quadratic. Now we're going to learn about a couple more. So there's two other interesting features about a quadratic. There's something called a focus and a directrix. So let me draw just a quadratic. It really doesn't matter where it is. Okay, so let's say my vertex is there. There's something called a focus. It's what the quadratic focuses on, for lack of a better word. And the focus is inside the quadratic. Let's say it was here. There's also something called a directrix. In our case, the directrix is right here. There's two things I want you to notice. First off, the focus is inside of the quadratic. The quadratic is wrapping around it. And the directrix is on the outside. Every single point on a quadratic is actually the same distance from the focus as it is from the directrix. Now my drawing isn't very accurate, but it is. So as I move the focus away from the vertex, my quadratic would open up wider. The closer it is, it'd be narrower. Now, that all being said, I want you to notice that since I said that the focus and the directrix were the same distance from any point on the graph, they're the same distance from the vertex. In our case, they're 2 steps away. 2 steps here, 2 steps here. So, how would we find the equation of this graph if we knew this information? Well, there's some key things here. First off, we know that we can use the vertex to help us with vertex form, right? The vertex form was y equals something. Now that had to do with whether we were open wider or narrower. And then the parentheses would be x minus h squared plus k. Now that h and k have to do with our horizontal translation and our vertical translation. In other words, it's going to be directly connected to the vertex. If I moved right to that right h movements, my vertex would be at h, and if I went up k movements, my vertex would be at h comma k. So looking at this graph, I can find my vertex just from the graph. It's at 2 over 2 up. It just happens to be at 2, 2. So for our graph here, our vertex is at 2, 2. So continuing from knowing where my vertex is, I know I can plug in 2 for h and 2 for k. But what about a? We would have to know what the vertical stretch was or the vertical shrink was. This actually has to do with the distance to the focus. This distance actually helps me find a. There's a little formula that we probably need to write down. A is equal to, now it's kind of an inverse relationship. It's not direct. It's 1 over 4 times that distance. And we'll just call that distance P. So the distance here is going to be P. Guess what? The distance here is also P. So if I know that distance, all I have to do is substitute it in. So in our case, we have 2 as our distance. So A is going to be 1 over 4 times P. That's 1 over 8. Now, we also have to make sure we know whether our A is positive or negative. Positive is when we open up. Negative, we're opening down. So if we look at the graph, it opens up. So A is positive. Now let's see if we can write the equation. So we have y equals A, and A is going to be positive, 1 over 8, x minus the h value, which is our right movement, 2, squared plus k. Let's try a different one. What if we didn't know our vertex? What if all we knew was our focus and the directrix? Okay, so let's say I told you that the focus was at trying to find a good one. Focus is at -0, -2. Oops, sorry. And the directrix is the line y equals, let's say, 6. Okay, so in your book it gives you a very long explanation of how to do this. I want you to think reasonably. So let's sketch it. So we make our little graph. Focus is at 0, -2. So 1, 2. There it is. 0, -2. That's my focus. Directrix is the line y equals 6. Y equals is a horizontal line. Remember, it's a constant. 1, 2, 3, 4, 5, 6. And the directrix is a horizontal line. So we have our focus and we have our directrix. We need to know our vertex. Now let's think about what was happening in the last one. The vertex was exactly halfway between. So the vertex is halfway between. So let's start with how many steps we are apart from the focus to the directrix. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. So halfway would be 4 steps. 1, 2, 3, 4. Right there. That's going to be my vertex. I'm going to call it V. So what point is the vertex at? 0, +2. Ooh, that's helpful. Vertex form. That means my HK is 0, 2. Now all I need to do is find A. And I need to know whether A is going to be positive or negative. So I need to know if this graph is going to open up or down. Well, it focuses on the focus. Runs away from the directrix. So if I'm focusing on the focus, that means I've got to hug it. I'm going to hug it this way. That means I open down. So whatever we get, whoops, I can't spell down today, our A is going to be negative. Y'all got the point, negative. I just need to know the value of A. So A is 1 over 4p. P is the distance between the vertex and the focus. So how many steps was that? 1, 2, 3, 4. So P is 4. So 1 over 4 times 4. 4 times 4 is 16. And when I write the equation, I need to make sure it's negative. So let's start. We're going to start with vertex form. Y equals A times x minus h squared plus k. A is 1 over 16, but my graph is opening down. So I'm going to put in negative 1 over 16. X minus h. Well, since I didn't move right or left, that's going to be x minus 0, which you're welcome to put. Plus k. It was up 2, so that's plus 2. Now, I also could write that as x minus 0 is just x squared plus 2. Let's try another one. What if, so let's see, we did a focus and a directrix. What if we had, I don't know, a vertex and a directrix? And then the directrix was at y equals negative 5. Again, my suggestion is to sketch a graph. So negative 5, I need to make sure I've got enough room there. So negative 2, 1. 1, 2, negative 2, 1's right there. There's my vertex. The directrix is at 1, 2, 3, 4, 5. That's the directrix. That's a horizontal line. Now, which way is my graph going to open? So the vertex was halfway between the directrix and the focus. So how many steps is it from here to here? 1, 2, 3, 4, 5, 6 steps. 6 steps that way. So that means that the focus would be 1, 2, 3, 4, 5, 6 steps this way. So let's see. That focus would be at negative 2, and I went up 6 steps, right? We counted up 6 steps. 1, 2, 3, 4, 5, 6. Okay. So that y value is at 1, 2, 3, 4, 5, 6, 7, because I went up 6 steps. Oh, that got fuzzy. Sorry. Which way is the graph going to open? What's going to hug the focus? It loves it. It's going to hug it. It's going to go something like this. Now, I'm not so concerned about my graph being accurate. The thing is, I'm just trying to figure out if it opens up or down. This one opens up. So A is positive. We need to find the value of A. A equals 1 over 4 times P. P is the distance from the vertex to the focus. Well, we counted 6 steps up because it was 6 steps this way. So that's 1 over 4 times 6. That's 1 over 24. And it's going to be positive because we're opening up. Now, the only other thing I need for the equation is my vertex. X is h, and that's the k. Y equals a times x minus h squared plus k. Y equals, we found our a. we found our vertex. So x minus a negative 2 turns it to plus 2. Plus 1. Question. Where's the axis of symmetry? Oh, axis of symmetry not only is going through my vertex, but it also goes through the focus. My axis of symmetry would be x equals negative 2. What would be my domain? Oh, that's a silly question. It's a parabola. The domain is negative infinity to infinity. What's the range? Well, the smallest value on our actual parabola is right there where the vertex is. And this is a minimum vertex at 1. So it starts at 1 and goes up from there. Now the next thing you're going to have to be able to do is take the equation and work backwards. So let's say we had f of x equals, oh, I don't care, negative 1/4 x minus 1 squared plus 3. So let's think. Okay. So A is 1/4, but it's opening down, so we need to remember that. Opens down because of that negative. Opens down. We need to find our vertex. Well, that's easy. This is in vertex form. Vertex form tells me how my graph translated. It goes right 1, up 3. My vertex is at HK, which would be 1, 3. So over 1, up 1, 2, 3. There's my vertex. It's going to be opening down. So for this, we're not doing very accurate graphs. We're just going to kind of sketch it. I need to be able to find my vertex, my axis of symmetry, vertex done, axis of symmetry, focus, and directrix. So let's start with the first one, axis of symmetry. That's that imaginary line splitting the graph in half, going straight through my vertex. Well, we've been doing this for a while now. That's going to be x equals 1. Easy. Focus. I need to figure out how far away the focus is from the vertex. Well, there was something about A equaling 1 over, so let me come over to the side, A equals 1 over 4 times the distance. So 1/4. 1 over 4 equals 1 over 4 times that distance. What does that distance have to be? Well, this isn't easy. It has to be 1. So we're 1 step away from finding our focus. So 1 step from the vertex is going to be my focus. Which way is the focus going to be? Well, the graph hugs the focus. It focuses on it. It loves it. It's got to be inside. That is the focus. So what are the points, what's the coordinates for that focus? It's over 1, up 2. So 1, 2. What about the directrix? Well, remember, it was the same distance from the vertex. The vertex was halfway between. So if this was down 1 this way, then my directrix would have to be back here. That's a horizontal line, so it's a y equals, and it's y equals 1, 2, 3, 4. What's the domain? Oh, silly Miss Zimbritsky, it's always negative infinity to infinity. Don't try to fool us. What about the range? Okay, so think about it. the parabola has a maximum value where the vertex is. That's the biggest y value on the graph. It's at 3. Everything else is below that. So that means I'm going from negative infinity to 3. One more where we find it from the equation. So let's do a really good one. F of x, y equals, doesn't matter, 1 over 20 x minus 4 squared. Yeah, and that's all I'm doing. That's a parabola. Which way is this parabola opening? It opens up. And it is shifted 4 to the right. So that means 1, 2, 3, 4. That's where my vertex is. It's at 4, 0. And notice I'm not adding anything at the end or subtracting, so yes, the vertex is at 4, 0. I even know that that means my axis of symmetry is at x equals 4. I don't even need to draw it anymore. And I'm opening up, something like that, a lot wider, but I'm just sketching. To find the focus and the directrix, I need to know how far away they are. Well, A tells us about that. A is 1 over 4 times that distance. And this A is 1 over 20. So 1 over 4 times what gives me 1 over 20? Well, P would have to be 5. 4 times 5 is 20. So 5 steps away. I probably shouldn't have drawn it there. Oh well. 5 steps away. 1, 2, 3, 4, 5. Puts me right there. So let's find the point of the focus. It's over 4, up 5. So the focus is at 4, 5. Now I need to know where the directrix is. The directrix is a horizontal line. And it's also 5 steps away, but in the opposite direction. 1, 2, 3, 4, 5. So that's at negative 5. What's the domain? Being silly, we know it's negative infinity to infinity. What's the range? This is a minimum at 0, and it goes up from there. So, on the back of that homework, your 2.2 homework, there's 2.3. Now, the instructions on there are really crazy. They're not what I want you to do. It says to use the distance formula. No, that's silly. I don't want you to use the distance formula. I want you to sketch the information given and then write the equation. So you're going to do that and then find all the missing information on numbers 1, 4, 8, 16, and 18. We don't need a lot of these.